Alright, time to work on a video for significant figures. Or I could play Uncharted 4. No, do the video game later. But Uncharted 4 is Uncharted 4. No, when you first started doing these things, you swore that you would do them on a regular basis, and you wouldn't be distracted by any games or stuff, no matter how awesome the game turned out to be. No, game later, video now. Game later, video now. Or
so significant figures are the digits in your measurement or calculation, depending on what you're doing, that you have the highest certainty about. The numbers, the digits that you think are the most accurate. Now, when you're making the measurement yourself, like in a lab, the number of significant figures you record depends on how many you see. Now, people will tell me all the time, ask me all the time, how many significant figures should I write in my data sheet? My response is always, how many do you see? When you're working with a balance, if your balance goes out to just the first decimal place, then that's how good your certainty is. So you can only write out to the first digit. If you have a more expensive balance that goes up to the third or fourth decimal place, then you got more sig figs you can work with. Oh, there he is. So, or a beaker, is usually graduated, 50, 100. You're not too certain about the measurements in between. Like you are with a graduated cylinder that's graduated out usually by ones, 25, 26, 27, and so on. So when you're making the measurement, it depends on the type of instrument you're doing and how many digits you actually see and are certain about. And on the lecture side of things, what you have to worry about is, you've got, say some problem or word problem, and the data's been given to you. And you have to look at those numbers and be able to figure out how many significant figures have been given to you. So if the number isn't a zero, then you just assume that those digits are significant. Otherwise, they shouldn't have given you those digits. For example, the number 685, 3 digits, 3 significant figures. I already know where I'm going. Because this isn't the first time I've played this level. I'm not going to do this for the first time I've played it. That's crazy. Actually, a true story. This is actually the second time I've tried to do this, and the first time I did it, I've tried to do it on crushing, and yet you can't talk to somebody and pay enough attention to get through this on crushing. How about that? So I think it's moderate. But anyway, so again, if the number isn't a zero, you assume it's significant. The zeros is where it gets a little bit tricky, because it depends on where those zeros are, whether or not they're going to be significant. And so, almost rolled right in front of them. So if you have zeros at the front of a number, or left of the first non-zero digit, or leading zeros as they're sometimes called. I just like to call them the numbers in front. That makes the most sense to me. Those zeros are never significant. The reason is pretty simple. If you convert to scientific notation, they go away. So if you have 0.0685, you convert that to scientific notation, it becomes 6.85 times 10 to the negative 2. You don't write the zeros because they're not important. They're just placeholders. And if they're just placeholders, they're not significant. They're just trying to get that first non-zero into the proper decimal place. So I was going to sneak around, but I can blow them up. Oh crap, didn't do it. So the ones at the front of a decimal, or the front of the number, they're never significant. Ah crap. So the ones in the middle, they're always going to be significant. Like the number 0.0685. I'm sorry, 0.06085. I might have screwed up. Hey, where'd you come from? There you go. Again, the zeros in front, they're never significant. But when you convert to scientific notation, that's boink. When you convert to scientific notation, that 0 between the 6 and the 8, it doesn't go away because it's not a placeholder. It's part of the proper measurement, the proper number. So, get out of here. So again, the ones in front, they're never significant. The ones between two other numbers, the ones in the middle, they're always significant. So did I get them all? No, there's one more. Where'd he go? Hey, buddy. So the zeros at the end of a number, or trailing zeros, or zeros right of the last non-zero number. Again, I like to call them the ones at the end. That just seems simpler. Those numbers are significant, or may not be significant. Where do you come from? So maybe they're part of the proper measurement, or maybe they were just rounded zeros. There's some ambiguity there, and for me, people handle zeros at the end differently. For me, I like to say those zeros are only significant if you see a decimal place. If you don't see a decimal point, you should assume they're placeholders, kind of like the ones in front. So you take the number 6,850, no decimal place or decimal point. If you don't see a decimal point, you're not that certain whether or not the zeros are, oh crap. You're not that certain whether or not the zero was actually measured, or maybe you got a number that was rounded to 50. You're not sure, and if you're not sure, then you really shouldn't count it. So that's, I can't remember how you get up there. Oh, there it is. So again, I wouldn't count that zero, and I would just keep it at 3 significant figures. If you're making the measurement and you want to make it clear that that zero is significant, the way I like to do it is just to make it absolutely clear, you add a decimal point. And if you just add a decimal point, which is technically okay, then that zero would count and you'd have 4 significant figures. A lot of people don't like just a decimal point because it looks a little bit like a period. So most people add a 0.0 if it's, ends in the ones place. So when you add that new second zero that you've added at the end, that is also considered to be significant. So that would give you a total of 5 sig figs. The 6, the 8, the 5, and the 2 zeros at the end. So again, remember, zeros at the front, never significant. Zeros in the middle, always significant. The ones at the end, at least for me, only if you see a decimal place. Now, one sort of exception to, I guess this is an exception, if you will, to what I just said, was, if you have what we call an exact number. Exact numbers are said to be infinitely significant, so there's no uncertainty. So, if you have, if you know that the number is exact, like in the metric system, there's exactly 1,000 meters in a kilometer. There's no uncertainty to exact numbers, so they're said to be infinitely significant. And basically what that means is you can add decimal places an infinite number of times. You have infinite zeros after the decimal point. But never assume that a number is exact. Only treat it as a number as exact if you're specifically told that the number is exact. Like the this is the sliding part. Like the metric system. Metric conversions are exact. A centimeter is exactly 2.54 inches. I'm sorry, it's the other way around. An inch is exactly 2.54 centimeters. But if you're not told that a number is exact, then assume that it's rounded. So one more other thing we'll talk about as I jump on this guy is a little bit about how you do math and can factor in significant figures. Because you tell your calculator to do math, it's not going to round for you, at least not yet. If they do, good. That'll be one less thing I have to talk about before I get to atoms in chapter 2. I never noticed until the third playthrough that this guy's actually peeing. Anyway, yoink. It's all in the details, Naughty Dog. So, so you have to round. Your calculator's not going to do the rounding for you, or round correctly, with the correct number of significant figures. And how you round depends on which operation you use. If you're doing addition or subtraction, you're going to go by the common decimal place, or I guess technically numeric place if it's in the ones or higher. So for example, say you're adding 12.4 to 8.772. So you tell your calculator, hey, do this for me, and your calculator says, sure. Here's the answer, 21.172. Thanks, calculator. You're welcome, person. No, calculator talks for some reason. But again, it doesn't factor in rounding. It just does the math for you. I wonder if I can sneak by these guys and talk at the same time. I know I can't if I wasn't talking. But so the reason you go by the common decimal place, or whichever number has the fewest decimal places, that's where you'd round to. Same difference. Is if you look at that problem, you don't know what's after that 4. If you have 2 zeros, then the number is going to end in 7.2. If it's anything else, it's not going to end in 7.2. You're not that certain about the 7 and the 2. And again, significant figures is all about certainty. So if you're not certain, you really shouldn't count it. We would want to get round to the first decimal point. And so our answer would be 21.2. And for me, I just do the simple 5 and up rounding. If it's 5 and higher, round up. Otherwise, round down. There are more nitpicky things about rounding that I don't bother getting into in general chemistry. But when you're multiplying numbers, let's say you multiply those two numbers, you tell your calculator, hey, multiply these for me. Your calculator is going to say 108.7728. Ah, crap, he saw me. Did he? Oh, nope. So with multiplication or division, the thing you're going to look at is the number with the fewest decimal places, or the number with the fewest significant figures. And you're going to round to that many significant figures. The reason is for the same reason we had the question marks with our addition subtraction, but to see the question marks in a multiplication or division problem, you have to do long multiplication or long division, and a lot of times it's just not worth to do that. So maybe if I have time, I'll flash it on the screen when I edit this thing. But otherwise, just trust me, there's similar reasons, but you gotta do long multiplication. So for this particular problem, we have 12.4, which has 3 sig figs, and 8.772, which has 4 sig figs. Number with the fewest has 3, so we're going to take our answer and round to 109. Oink. So that's it. I am going to, actually. So thank you for joining me in my first attempt to teach a class and play a video game at the same time. I don't know what I'm going to call this. Chemistry and murder. But anyway, maybe I'll do it again next time I don't feel like doing this. No, I don't know, we'll see. If this wasn't just a total disaster, let me know, and maybe I'll try something like this again. But otherwise, see ya. Come here, you son of a bitch. Leroy!